Hello, hello. This is Marek here. Just a quick sound check. Can someone please confirm on the chat that you can hear me loud and clear? Then I'll know that we can continue. Right. Okay. So I can see that you can hear me just fine, which is really good. So once again, warm welcome to this hopefully short but insightful session on AWS and log monitoring. My name is Marek, for those of you who don't know me, and I'm a managing architect at Netcompany. Um, I specialize these days, at least, in AWS, and I've been for the past 2 years or so. I've been on this quite a large project at a Danish insurance company where we are delivering a CRM system and a core policy system. So quite big implementations. Um, so as uh, as a member of this project, I'm currently heading a team of integrations. We are mostly dealing with external integrations, but also have somewhat supportive role. So whenever something non-standard needs to be built, then we are called for, and we deliver that. Actually, let me just close the door behind me. I just noticed that my coffee machine started buzzing, so we don't want that to happen. Right, before we move on, before we start talking about AWS and the technical part, just wanted to set some ground rules, some housekeeping. So, for your information, I have never ever done any live streaming before. So I don't know what sort of surprises await down the road. I'm not sure what to expect. I can already tell it's going to be weird because there's no feedback from you guys, so I can't see you. I don't know if you're bored already. I don't know if you're laughing with me at stuff. So this is gonna be pretty difficult. But what I wanted to say is there will be because YouTube buffers content so that you don't experience too many lags. There's gonna be a bit of a delay, right? A lag actually. So you will actually hear me. Cedric is not bored yet. You will actually hear me, and with a little bit of delay, right, which makes this real-time interaction very difficult. So um, I will be looking at chat from time to time, and I will be making probably a little pause after each slide, so that if someone wants to post a question, right, they have a chance to, which may look as if my brain disconnected for a minute or two. It's not going to be that. I will actually be waiting for the questions that might come up. Yeah. All right. So I think we are done with the introduction. Thank you so much for joining me and for giving me this great opportunity to actually put on a shirt and pretend that life is normal again. So I'm going to switch over to the presentation view now. Just bear with me. Yes, there we go. All right, so let's actually start. I hope you can see my screen now. So I'm going to get into the presentation mode and walk you through this solution that we have recently built. Um, So, a short agenda of the meeting, because you should always have one. We're going to start with a brief Netcompany intro. So, I'm going to just very briefly talk about who we are as a company and where we came from. I also prepared a slide on my pro tips on how to stay mentally sane when you're working from home every day and you can't really go out, right? So these days there's lots of people giving lots of advice on lots of things, and I figured, well, I can do the same, right? And I actually worked from home before it was fancy a lot, so I have my tips and trick that hopefully can help you get through the day in those weird times. Right, then actually, I want this. I want to structure this talk in terms of a problem that arose on our project and a solution that I or me and my team came up with to that problem. So we'll discuss what we faced and how we attempted to find a solution for it. Um, and that solution is a component, a tool, a simple application that I called Logmon. This is the name I came up with, so you can tell it's not very fancy. So we are going to talk about the architecture, and then we are going to take it apart. And my idea is that I will, for every single functional component of that application, I will first introduce an AWS service or component that it is based on, and then talk about what it does in detail. Um, Finally, I want to mention security because I think the security setup is also pretty interesting, and it's very rare these days where you can build something that doesn't have to be integrated or connected to many other services that are out there already, right? And this is a case in point, basically. The client already had an established IT infrastructure, and we had to just make it fit somehow. So this is, I will show you how the security bit was solved with this particular case. Then, if I don't get to address the questions, after each slide or somewhere in between, we'll have a brief moment to ask questions and answer them at the very end. And I'm hoping to be done in an hour or so. So that shouldn't take us too long. All right, moving on. Netcompany, who we are, where we came from. So we are originally a Danish company, although in the recent years we have established a global presence. Currently, we operate in 6 different countries. We are a software house, but also an IT consulting company, right? So we consult on how to build software, but we've also built that software for you, which at least makes me very happy because we get to get our hands dirty. So if you want to know more about us, or if you want to know more about career opportunities, then I encourage you to reach out to our website, reach out to our HR team, especially here in Poland. They will definitely give you more info. I can only say that right now we are over 3,000 worldwide, so that's quite a number, and we are still growing. Yeah, so that's a short bit on Netcompany. I will actually slightly reorganize my windows so that I can see the chat. Okay, no one is saying anything just yet. That's good. Um, Moving on. Yes, my pro tips on staying sane, right? There's a reason why I'm actually wearing a shirt today. I actually put on cologne. That was really weird. Then I realized I really didn't have to. But I did put on some cologne just for you. And I just wanted to say that even though it may not seem possible, we should try and live our lives uh, normally, right? As normal as it can get when you're staying in home. So, like I said, I did work from home a lot. I actually have lots of colleagues whom I visit or used to visit when it was still an option that work from home 100%. And I would show up at their place, and I could tell that they haven't had a shower for 3 days, grimy hair, all that. I suggest you don't do it, especially when we have to stay at home for weeks, right? So my pro tip for staying mentally healthy and mentally sane is basically stick to your daily routine. If you had a routine before the virus or whatever is going on right now, try and stick to it, right? I used to go to gym on daily basis, give or take. Now there's so many online classes that you can watch on Facebook or on YouTube or whatever. So I still exercise every day. Of course, it's not the same thing. I'm not saying it is, but it's still I still get that opportunity to move a little at least, right? I do work and nothing really changes in terms of what we do in on daily basis in our work. I try to play games or read or whatever just to kind of like have live normal days, right? So yeah, when you get up, take a shower, brush your teeth, put on some pants, right? Don't be this guy who sits in front of a camera in a tie with no pants underneath. I actually do have pants, but I won't show you. Um, and also, for some reason, people don't want to do it, and they've never wanted to. But I really suggest you use a camera for every single online meeting. And actually, for these days, you should call people even more than just text them on IM or whatever. We need that face-to-face interaction even more. So remember about cameras when you have online meetings. And that's it. That's it. When it comes to my pro tips for staying sane in insane times, we can move on to the next slide, which is actually now on topic. This is the first slide, which is on topic. Sorry. Right. So I actually haven't introduced this component that we are going to talk about properly yet, and it will happen shortly. But I want to talk with you about the overall landscape of the solution that we are implementing at our clients. So basically, like I said, we are implementing two very big platforms. A so-called, I'm not sure if you'll be able to see my cursor. I think you should. We are implementing a system of engagement. This is basically a front end to everything. This system of engagement, which is on this right-hand side that my face covers at the moment, um, this is your that mostly serves as a UI to the entire back end of systems that are behind it. And this is basically used as by clerks, by insurance sales agents for daily sales for daily policy sales and daily interaction with customers. On top of, and this is a cloud solution, nothing to do with AWS. It's just a cloud solution, right? Then the next new system that we are implementing, it's referred to as a system of records. This is the red square on the screen here. This one is actually the core policy system, core billing system, etc. So this is the one responsible for actually generating policies for your customers, billing your customers, invoicing, etc., etc. On top of that, there is a bunch of legacy systems in the company. There's a legacy master data system. There is a legacy document generation system, and a plethora of other systems that all take part to a greater or lesser extent in processes that basically result in policy sales, because this is what we are talking about. That said, there's also this integration layer that I am personally responsible for that integrates those applications with the outside world. So there's a bunch of external systems that we have to communicate with. And this is something I talked about in my previous tech talk, which just introduced this integration layer in detail. So This is the integration layer itself, and then all the external systems that it talks to. And all of those systems, they talk to each other at all the time, basically, right? So you've got your system of engagement naturally closely integrated with system of records, but not only, because the system of engagement, the cloud one, actually talks to at least one legacy system that I am aware of. Uh, then then there's outbound calls, right, that go through the integration layer from the system of records and system of engagement. Actually, from legacy as well. Now that we build it, then legacy uses it from time to time as well. And it actually is the case that some processes, they are uh, initiated at the system of engagement. So let's say someone wants to quote a customer, right? And then turn that quote eventually in a policy. And got that those this process actually initiated here involves multiple calls to system of records, system of engagement, system of records to the external systems, for example, to fetch customer details based on the CPR number or their social security number. um, so we are talking lots of different processes, which can be both synchronous and asynchronous in nature. My important web camera to the left of the slide. Yes, I can move it, but there we go. Um, yeah, a lot of things going on. And at each of those stages of communication, where everything communicates with everything else, something can fail, right? And because this is the thing, then we needed some system for proactive, or kind of proactive monitoring of log messages that would allow us to um, react to errors, if any errors occur, at different stages of processing, and basically raise incidents in the company's incident system, so that someone can take action. And first and foremost, so that we know something went well, because especially when it comes to those asynchronous processes, lots of batch jobs in the background, um, the results not always show up in the UI. So quite often there wouldn't be an easy way to find out that something failed without actually looking through the logs. And if you can imagine, when we go just look at that, there's a storm of logs basically being generated every minute from every of those applications. So it would be impossible if we wanted to, manually monitor it. We would need a team of people actually to do that. So we were asked to deliver something that would get this done at least for a while. The requirements were that it would be quick and dirty, and I'll explain why shortly, and that it could be based on an extensible and configurable set of alerting rules. So someone could define what an error actually is and how to respond to that error. We needed to be able to generate immediate notifications with some actionable suggestions on how to resolve the problem. And the requirement was also that we leverage whatever's out there already and not build stuff from scratch if there's something we can reuse. Um, and this, we were asked to be very pragmatic about it and build something really quickly and make it really simple, because the customer is actually in the process of procuring a system from Elasticsearch, I think, which is going to do just that. But of course, the procurement process takes time. Probably is going to take months. And given the recent unfolding of events, it will probably take even longer. So this was something we were asked to deploy something, to implement something that would work for half a year or so. I think it's going to stay there for a bit longer, but it is fairly simple in nature, but that was also my point when preparing this tech talk, so that I can show you how easy it is to build applications when you have all the cloud toys that you can play around with. So we know the problem. There's a lot of applications. They talk to each other all the time. Errors happen in between, and we need to know when those errors occurred and that some action needs to be taken to address them. And the solution to that is, ta-dam, ta-dam. Okay, I'm going to move my face now to the right. Sorry, just this face. So the solution we came up with was, hey, let's have all those applications, all of them, log to a centralized log repository that will have some search capabilities out of the box. And then let's build something that will be looking at those logs on periodic basis, and whenever it finds something that it considers an error, it's going to issue an alert, and that alert will then get converted into a ServiceNow incident. So ServiceNow, I think if you haven't lived in the rock for the past 20 years, you've heard about ServiceNow. This is a incident management and service request management system that pretty much every company uses these days. Is the same thing with our customer. So that is that was my idea, basically how to approach the problem. And we are going to talk about specifically this logmon component, because this is something we built. Actually, the Elasticsearch service had already been used by the client at the time, fortunately. Excuse me. Fortunately, as a central log repository, so we only had to make sure that all our applications log to there, and then we could actually think about building some automated monitoring solution. Okie doke. So this is the solution that I have come up with, and now we are going to take it apart, like I said, and talk about every component in detail. But first, uh, sorry, yes, the architecture, the overall architecture, and the overall, solution landscape. And this is actually a slide from. So it is the picture is slightly different than the ones before, because this is actually a slide from the documentation. The tool documentation, we use Enterprise Architect on the project, so this is how I use component diagrams these days to model cloud applications. So you'll see this very natural division into application layer, right, where the processing happens, basically where your quote unquote business logic lives, and then you have your repository layer. This is where data is stored, right? Naturally. So how does it work really in detail? So this is going to be a summary, and then we'll talk about each of those more in a bit more detail. So um, everything starts basically with alert definitions. So there's a repository. It's actually a DynamoDB database, but it doesn't matter at this point. But there's a database which has a set of alerting rules. So those rules have a bunch of fields that determine when they should be run. So what sort of time window, for example, only 9 to 5 or 24/7, etc. And the key to those rule definitions is that they actually have a field which stores a part of Elasticsearch query. So it's simple as that. Every single rule describes some sort of error that happened, and it defines the search criteria for Elasticsearch uh, that if met, then it means an error occurred and an incident should be created. So how it works, on a periodic basis, currently every 10 minutes, a CloudWatch schedule invokes our query Lambda, or logic function that is a piece of logic that is responsible for reading the alerting rules from the repository, so getting all the rules that are applicable, so all the rules, for example, that should be considered in this time frame. It executes queries against Elasticsearch based on the query strings that are stored as part of the rule or alert definition. And if it finds any errors, it combines um, the error messages from Elasticsearch with some alert definition fields. I'll talk about them in a bit more detail later on. It combines these together and creates an alert message that gets put to a queue. So there's a queue in between two application components to decouple them and also to give me an out-of-the-box retry mechanism for free. And I will also explain that in detail later on. So once an alert like that is placed to the queue, an event gets generated, and that event basically invokes another piece of logic, another Lambda function, and that Lambda function does two things only. It checks if an incident with this particular alert code already exists. If yes, it's going to update that incident. If it doesn't, then it will create an incident and fill it out with a bunch of fields that are basically a combination of the actual error message that comes from Elasticsearch and also some, well, I could call it metadata or alert definition coming from alert config repository. Then, of course, the fact that the incident was created and some information gets, like incident number that got created or updated, that gets stored in a history repo. This one isn't really important. It's just for me so that I can basically monitor the behavior and make sure that things go smoothly. Of course, ServiceNow, in case you're wondering how we communicate with ServiceNow, naturally ServiceNow exposes a set of REST APIs which allow you to create incidents or update incidents. So actually, it has both REST and SOAP APIs in case you wanted to use the a bit older technology. So this is how this is basically the overall landscape. And now we can, I think, move on to talking about individual components. And I'll look at the chat, give you a moment. No one's writing anything, no one's interested. People asleep, I guess. Yes, someone is asking for a dead letter queue. Right, the dead letter queue, and I'll explain that also in a bit more detail later on. But basically, the dead letter queue, or DLQ, stands for dead letter queue. This is where alert messages that don't get processed successfully end up. So when I was designing this, I imagined that, hey, there can be a scenario, for example, where an alert gets generated, but ServiceNow is temporarily down or something, right? So I actually use SQSQ not only to decouple, but also as a retry mechanism. And the queue will try to reprocess the message 3 times before it actually fails. And if it fails for 3 times in a row, then it's going to move the message to the dead letter queue. So this is a standard mechanism in enterprise integration, basically, that when you have a messaging system, you quite often you have a dead letter queue where messages that could not be successfully processed end up. I'll talk about a little bit more. I'll talk about it a little bit more in the subsequent slide. All right, I'm gonna go to the next one. Just this is not this particular slide is not like directly connected to Logmon, but I just wanted to let you know because this isn't something I knew like a year and a half ago, let's say, when I was figuring out how to log from AWS to Elasticsearch and somewhere else. Like, what's the easiest way to actually stream logs from AWS? And this is actually by using something called CloudWatch subscriptions or log group subscriptions. So basically, this is a short interlude. AWS has this service called CloudWatch, and it does a bunch of things, but the most important is that it's a dump for all the logs from all over AWS. Whenever you issue a log console.log or whatever system out print whatever in your Lambda, it's going to end up in CloudWatch in a log group. Whenever API gateway logs requests responses, these end up in CloudWatch in a corresponding log group. Whenever you set up a cluster and it boots up and there are some bootstrapping steps that log information, this will end up in CloudWatch. And that makes things super convenient for you because you don't have to worry about, there's nothing non-standard about logging in AWS. Whatever programming language you use, whatever tool you use, you just like issue a standard log statement and things end up in CloudWatch. And then CloudWatch has this native capability to stream your logs further. So you can subscribe a log group, and these are log groups highlighted in yellow, and then they are subscribed to a Lambda, because you can subscribe a log group to either a Lambda or directly to Elasticsearch. But actually, if you subscribe it directly to Elasticsearch, it deploys a Lambda function, which then just streams to Elasticsearch, does a bulk insert. So I actually use my own Lambda function where we have more room to define the index name and index schema, basically, or the structure of the messages that get streamed. So super easy. Just remember about it that logging in AWS is super easy, and streaming those logs somewhere else is even easier. Just subscribe them to a Lambda function, and then Lambdas can do pretty much anything. By the way, another cool feature of CloudWatch is the so-called rules, which is basically your AWS cron. So whenever you need to schedule a task or schedule something, you will use a rule. And so before, when I said that, well, there's a CloudWatch rule here in this slide, that's what I meant, right? CloudWatch actually also serves as a cloud-wise scheduling engine. Okay, that's it about streaming. So now, alert configuration in DynamoDB. Let me just get a sip. So DynamoDB is not the best choice for this particular scenario, and I'll explain shortly why. But I actually selected it because we already had lots of boilerplate code for interacting with DynamoDB. So we had our wrapper classes around standard AWS SDK for basically just inserting and fetching data from Dynamo. What is DynamoDB? It's a fully managed NoSQL database in the cloud that pretty much scales infinitely. It has flexible schema because you can either insert key value pairs in there, or you can insert entire documents, right? It has super low millisecond latency. It's super fast, and it's this latency is retained even when you have, a petabyte scale table, right? So even for very massive workloads, it is able to still offer consistent performance and consistent latency. And actually, AWS claims, and I don't remember those numbers, but yeah, AWS claims that it's able to support more than 10 trillion requests per day with peaks greater than 20 million requests per second. So it's quite a lot, if you ask me. But there's a bunch of very standard applications for DynamoDB. So you will want to use it for storing caches. You will want to use it to store user sessions. This is a very, very common example. Shopping carts, etc. Basically, whenever you have a stateless, serverless application and you need to induce state on that application, as if you were storing something in memory, let's say, this is where you use DynamoDB. Um, and if you look, when I say flexible schema, if you look at the table definition, so the picture in the top left part of the pictures here, this is the entire table definition that basically stores a pretty complex document. So this is a structure of a single record inside that DynamoDB. But the only things that I needed to define were keys, and well, basically attributes that constitute the primary key, quote unquote. These are not called primary keys actually, but never mind that. So this is why I love NoSQL these days so much, because you don't need those huge DDL statements like you would in the relational world that you need to change constantly, unless you're using some sort of framework that does that for you. So with Dynamo and other NoSQL databases, you can go code first, right? People say it's schemaless. It's not, because the schema actually lives in your application. You need some sort of structure to your data, but you don't have to define it and as part of your table definition. So this is pretty cool if you ask me, right? Just I don't know, 10 lines to define a table that then can store pretty much anything. The only thing required now is that I have two fields, which are index name and alert code, and that's it, right? I don't have to care about anything else. Now, in terms of our alert configuration, because this is actually the most important part of this application, is this alert configuration. So the important things here, and I hope you can read that, or at least read some of it. The important thing here is an alert code. An alert code is a unique alert identifier, and this is used to check if there's already an incident for that particular alert in ServiceNow. So it has to be unique, because otherwise we would just duplicate incidents and we would get probably a flood of incidents for no reason. So the logic, this is used to determine if there already is an incident there, and then whether to create one or update the existing one. Then there's a bunch of configuration info like description, application, that doesn't really matter that much. What does matter is the index name and the query string. So, like I said, all those applications, they log to a centralized log repository on Elasticsearch, but actually they log to different indexes. Excuse me. So for every index, we have different query definitions, and different types of errors can be generated, different sorts of alerts. And I think the beauty of this configuration is this bit which says ES query string. So ES query string basically lets you define a query in terms of Elasticsearch syntax. I will briefly touch upon that later on, but basically we could have a whole tech talk on Elasticsearch syntax. It's so powerful, and we wouldn't really we would just scratch the surface of that topic. So this query string part is what makes this solution so flexible, and it's also what kind of gives the power and also the responsibility to individual teams for defining their alerting rules. Because I don't know their applications and I cannot say what is an error and what is not. So they've been asked to prepare those rules themselves, and they generate those queries. Like this is an example of a query that actually tries to make sure that a batch job finished, right? So it searches for a string in the log message called batch account finished. Never mind the details, but basically that's the gist of it. It also has a filter for time range, so it looks 1 day back, right? So it's always going to look 1 day in the past, and a bunch of other stuff that is not that really important. Another pretty interesting thing, I guess, we put in here is this ability to have negative results condition. So um, if that is set to true, then an incident gets generated when this does not return any results. So basically, this is so that we can check that some batch jobs, some synchronization, for example, has actually run in the background somewhere, as opposed to when this is false, then we create an incident if some results were returned by an Elasticsearch query. Then, like I said, there's this bunch of governing fields, so it determines if it should run 24/7 or not. Also, the interval milliseconds, so that if a rule was just processed, we don't reprocess it immediately afterwards. We have some resolution steps. So this is some instruction for the support team, actually what they should be looking at, right? So a link to a knowledge base article or whatever. And then a bunch of ServiceNow specific properties like categories or priority or impact, right? So this is what our alert definition looks like. And this plus Elasticsearch are basically the most important pieces of this application. Everything else is just a bunch of code that ties it all together. Speaking of code, yeah, I'll just look at the slide at the chat for a second to just make sure no one. Okay, right. So lambdas. Lambdas actually are responsible for making all that processing happen. And I have talked about lambdas in general in my previous tech talk, so I'm not going to repeat myself. The only thing you should know is AWS Lambda is a serverless code execution environment. You write code, you upload it to the cloud as a zip package, a jar, or whatever, and you don't care about any infrastructure underneath. AWS got you covered, right? You don't have to worry about it. But what I want to talk about in this particular slide actually is how we write our lambdas using TypeScript for Node.js and how we generally structure our repo. Because there were some questions before, people wanted to see what Lambda looks like how do you write a Lambda? And this is really easy because at the end of the day, you can see in the left hand side here, a Lambda is nothing more but in this case, a Node.js project, right? So it's a regular Node project with a regular or kind of regular structure. We have actually, everything that you should expect to see in a code project. We have our unit tests where we, unit test every single service or controller or whatever. So no surprise here. But some other interesting pieces are the stack definitions. So stacks are actually this is where the infrastructure as code gets defined, right? So this is where we write how those lambdas should get deployed. So that basically take the code from here and deploy it somewhere under some name, etc. We have our config files. These are just config files that store different configuration parameters depending on the environment that we use. And then a bunch of CI/CD files. So a Jenkins file defines the CI/CD pipeline that basically builds the code, runs unit tests, and then if everything is fine, deploys it. And deploy sh is basically logic that deploys the stack definitions on AWS. So this is how we structure our projects these days. A very, very simple, pretty standard, I should say, approach. But when it comes to the Lambdas themselves, I just wanted to show you the API that is required to create a Lambda because it's so easy that some people can't believe it, right? So the only thing that you have to do in order to code a Lambda is have a file that exports a handler function which accepts two parameters, some event and a context parameter, and then does something with it. And it's the same regardless of any of the language. For example, in Java, you simply implement an interface. You implement an interface which has a method, which has a handler method, which accepts, two arguments. So very simple, very similar approach. One thing I also highlighted, and I will get back to that later on as well. We are talking specifically about log monitoring. We are talking about monitoring distributed processes. We are talking about monitoring often asynchronous processes. So when I write my lambdas these days, the first line or almost the almost first line is always something that sets a trace ID. So if you want to monitor distributed components of an application, whatever application that is, you need some sort of, you know, tying a request chain together. And this is usually done through some trace ID that gets passed around with every callout. And this is what I do in my lambdas as well. So I have a method. The name is not that good, I guess, these days, because this common utils generate trace ID which accepts an event method. It basically checks if there's already a trace ID on the event. So it came from somewhere else. It's a part of an ongoing request. And if not, if it is, then it uses it and sets it as a property of the logger. If it's not, then it generates a new one, basically. And that trace ID is simply a UUID version 4, nothing really fancy, but only something that lets me tie multiple messages together that just may circulate across all those components that you've seen. Um, and one more thing I just wanted to recommend if you're running. So what I want to say, I guess, is that it's perfectly possible to deliver enterprise-grade solutions with Node.js, at least in the cloud when you're using serverless functions. Probably wouldn't dare to do that if I had standard, bare metal boxes to work with. But what you really should implement is, or you should try to do is use TypeScript. I tried writing my code without definite typing or strong typing for like 2 months, and I just got so frustrated that I couldn't do it anymore. And by now, we actually have a pretty decent object-oriented approach to writing our Node.js code. We are using abstract classes, we are using interfaces mostly, we are using generics, right? And that really makes reading that code easier, understanding this code easier, and also, of course, gives you the compile time checks that are so important when the complexity rises, basically. So I would never ever again attempt to write code without proper typing. And as you can see in those in those two rectangles, we have this. This is how we actually structure our lambdas as well these days. So usually a request is passed to a controller that's responsible for parsing that request, and then controller invokes some service or services to process it further and come back with a response. And you can see that it implements an event controller interface. This is actually a generic interface that controller accepts an event of certain type, and this particular one actually does not respond with anything because it doesn't have to. This is the one that interacts with the queue, so there's no need to respond with anything. So Go Node, it's really great and you can produce code really, really fast. Lots of libraries, great tutorials online, but myself, I would never ever try to do it again without TypeScript. TypeScript has really improved things for us, and we just generate much less bugs these days when we have compile time checks. Okie doke. All right, it's almost an hour. Okay, I have to. Actually, not. I think we are more or less on time. Um, all right, I can see then there's no questions so far. I hope it's either very clear or very boring, one of the two. Okay, another interesting piece, and perhaps I will move my uh, face to the middle just to confuse you even more. Um, Another piece or another component I want to talk about, and I think I should speed up a little, is the SQS. So SQS stands for Simple Queue Service, and I'm going to start by just explaining what a queue is, for those of you who have not heard about it. A queue is simply a data structure that is normally used to decouple software components, basically decouple and scale, right? So normally you will have your producers that produce some sort of messages. They get persisted in a queue, and then you have consumers that take messages off the queue and process them, do stuff with them. So naturally, the purpose of a queue is to serve as a communication channel between producers and consumers. And you use queues for a bunch of reasons. You use them, like I said, to decouple. You use them to send and receive messages when you have a messaging system or an architecture which is based on messaging in a way that nothing gets lost, because it's pretty much impossible to lose a message from an SQS queue. Um, you can use it for buffering, batching, right? So messages land in the queue first, and then once they reach, I don't know, a queue reaches a certain size, let's say, then you start processing them. Or also, you can use it to throttle your application or handle spikes in volumes without increasing latency, for example, or without again losing messages. Another application for queues, prioritization. You can have a bunch of queues and then uh, process messages and assign each queue a different priority and then process messages from them in, let's say, different order. Think about, I don't know, whatever online service that has standard users, premium users, right? Premium users requests would go to a queue with a higher priority, and standard users request would go to a queue with a lower priority. Um, so this is a queue 101 in terms of software architecture. Uh, but I want to talk about now specifically about simple queuing service from AWS. And funny fact, SQS is how AWS started. So this was the first offering from Amazon Web Services. I think that was offered in 2010, if I'm not mistaken, way back. And so it's been around for a while, and lots of enterprises use it in the daily operations. It's really stable, it's highly available, and it can pretty much handle unlimited throughput, right? You have a limit on the message size, but pretty much there's no limit on how many messages you can push through that queue. Well, there's limits, but it will be very hard to exceed them. Um, and this is what I wanted to say mostly about SQS. They have standard and FIFO queues. I also put that on that slide. Standard queues, which is something I use, they are faster and cheaper, but they do not guarantee message ordering. But I don't care. In my particular application, processing messages in order, which is usually also another reason why you would want to have a queue, to make sure that you process messages in the order in which they arrive. I don't care about that in this particular application, so I use a standard queue. If I wanted that capability, I would have gone with a FIFO queue. One important concept of SQS, and this is something that they ask about and at every AWS exam, so it's good to know. A queue has a setting called a visibility timeout. And this is something that I have highlighted here with, again, these are actual definitions from the stack template. These are actual definitions of the queues. So if you just look at those, how many lines that is, that's like 6 or whatever. Um, these are the entire definitions of the queue where the messages arrive and the dead letter queue. And with those 8 lines or so, I get for free a retry mechanism. I get decoupling of my components, and I basically get a way to look at failed messages by interacting with the dead letter queue. That's a beauty. But visibility timeout, coming back to that because it's pretty important. So SQS offers you a way of locking a message. So once something starts processing a message, so takes it off the queue for processing, it becomes invisible. It becomes invisible to other consumers. So as long as you finish processing your message in that visibility timeout or visibility time frame and delete it from the queue, then you will never have a scenario when some messages are processed twice. Sometimes it doesn't happen, so your application processes a message longer than the visibility timeout, and then it becomes visible again. If it does, another consumer will start processing it, and you might have a case where, for example, the same email gets sent twice because you put your email payload to the queue. There's a sender that then takes them off the queue and sends them as messages, right? If you got sent the email twice, probably your visibility timeout needs to be adjusted. So something from the field. And someone asked about the dead letter queue. So this is where this whole thing is defined. There's this redrive policy setting, and it's so easy to define. You just point it to the destination queue. In this case, it's my NIT logmon alert DLQ as the logical name of that component, and you set this max receive count. So in our case, it's 3. So if the message does not get successfully handled 3 times, then it gets moved to a dead letter queue. You have to have that because, well, there's various ways in which you could handle this redrive, but if you don't, then your messages will get stuck. Because if your message keeps failing, then the queue will keep retrying, right? And you will have bottlenecks in your queue. So it's a good practice to always have some sort of redrive or a dead letter queue in place so that messages that fail, they don't block your queue and subsequent messages that are waiting in the line. And yes, we are nearing the end. Just elasticsearch and we're done. Again, face goes to the right. Okay, there's a question why I used SQS instead of Amazon MQ. Well, primarily because I have previous experience with SQS. Reason number one. Amazon MQ, I think it's a JMS queue, right? It's an Apache queue, so probably if I was writing my lambdas in Java, I would consider that. I honestly don't know the price difference between Amazon MQ and SQS. I haven't considered that, to be honest. I kind of figured like, SQS was the queue for AWS, but obviously yes, this is not the only reason for me using. This is not the only the only queue service, sorry, that AWS offers. But like I said, it was just my personal preference in this particular case, which is something you will actually see quite often these days in IT. Uh, there's so many ways to skin a cat that every architect does some things their own way. I haven't even thought about SQS, to be honest. So I only thought about sorry about Apache MQ. I only thought about SQS. Okay, no more questions. Elasticsearch, security, and we are done. I promise. So uh, this particular offering from AWS is fairly different than everything we've talked about so far because DynamoDB is actually something AWS built from scratch. It's a native AWS product. Lambdas to an extent as well, right? What was the SQS? Maybe it's based on some JMS underneath, I don't know, but it is also a native AWS offering. It's slightly different with Elasticsearch because Elasticsearch in and out of itself is a full text search engine that you can basically just install on a bunch of servers and you don't need any cloud for it. And you can have it pretty much anywhere. And the standard, so like I said, Elasticsearch, when you hear Elasticsearch, think full text search capabilities. So anything ranging from, excuse me, the need to search large amounts of text data, excuse me, on a combination of keywords to log analytics, obviously, application monitoring, security analytics, clickstream monitoring. Even these days, I see more and more Elasticsearch being used as a database, right? It doesn't really have ACID support. You don't really have your standard, transaction kind of thing. It's not what it was built for. But more and more people use it for long-term data storage and data retrieval. So Elasticsearch originally comes from something called Lucene. So it's been around for a while, and it's a very great product. Like whenever you need to build something that offers free text search capabilities, just go Elasticsearch and add some sort of API in front of it, and you're done, right? You have an application that supports full text search. Um, Not only does it have those APIs for data retrieval, data storage, but also it comes with a nice user interface called Kibana. And you will normally hear a term ELK, Elasticsearch, Logstash, Kibana. This is a trio that is usually deployed together. Logstash is for log retrieval, Elasticsearch for log storage, obviously, and Kibana to basically search the log messages and visualize them. And I have a slide which actually shows a dashboard built in Kibana, and this is actually what we were having before we started this automated log monitoring solution. Um, we had a guy who would, look at the dashboards and take action whenever something was off. Um, so Elasticsearch, a really cool product in and out of itself. And then Elasticsearch Service is an AWS offering that lets you deploy an Elasticsearch cluster easily in AWS. Unlike previous offerings, this is not serverless. It's still a managed service, but it's not serverless. So you actually define how many servers or EC2 VMs should be used. You define if there should be a master node or not, and if that master node should be replicated, highly available, etc., etc. So there's a bit more infrastructure involvement that's required from you when deploying Elasticsearch service. But AWS handles everything else, right? For example, patching those servers, updating Elasticsearch version, etc. AWS will do that for you. But it's not as serverless as, for example, Lambda, when you don't even know there's a server in the backend. And why it's so easy to use Elasticsearch? Because in order to load data, you issue a simple post request, and in order to retrieve some data, you issue a simple get request. Or actually, usually it's post requests only with different combination of parameters, but I just wanted to separate this clearly, right? So, for example, if you look at that sample request HTTP post, well, if I just wrote HTTP post slash name of the index, and then in the body I put some JSON, that would create an index and load the document into that index. So it's that easy. By default, Elasticsearch has this option enabled where you don't even have to create an index up front. You can just send a first load to index message or post data request, and an index gets created for you, right? Super nice. And then retrieval. The retrieval is there's a massively, I don't want to say complex because it's not that complex. It's pretty intuitive, but massively powerful query DSL, massively powerful query syntax that you can use. And I only use the simplest examples because I don't know it that well. But for example, the first query that will look for the word for the string error in every single log message across every single field, whereas the second one will look for error, but specifically in the severity field, right? That easy. So you just type in field name, colon, and then whatever string you want, or just whatever string you want, and you can already retrieve data from Elasticsearch. Um, One pro tip also from the field when it comes to working with your indexes, we have this practice of rotating our indexes on daily basis. Or in other words, we create a new index every midnight. So we have an index prefix, which is always the same, application underscore logs underscore environment name like production, test, etc. But every day a new index is created. Why? An index also has a schema. So when you load data, you can of course define that schema up front. There's plenty of options that you have, but if you don't and you just create an index by loading data, it will try to infer the schema. And changing that schema is not that easy afterwards. So if you, for example, want to introduce new fields, where new fields can be handled fairly easily, I don't think you need to worry about that. But God forbid you need to change data type, for example, or you have a field which has to be unique or expect certain values, it gets pretty problematic. Sometimes you would end up recreating an entire index, which, if you can think about an index storing log messages for the last year, could be a pretty expensive and time-consuming operation. But if you cycle your indexes often, then you only need to, for example, drop and recreate the index for the last day, because today you have introduced a totally different schema for your log messages, and you need different types of indexes or a different index schema to be able to work with them. All right, so Elasticsearch is the thing that makes this whole application possible, basically, because otherwise it would be really difficult to write something that would efficiently browse all those log messages, or go through so many log messages to find the errors. Um, all right, this sums up the Elasticsearch part. We are going to the last slide. I was hoping to make it under an hour, but I failed. It's because I just talked so much. Uh, Security. Security is also an important topic whenever you have enterprise-grade applications, obviously. And it's also important because it can get pretty tricky, especially when you have to inject your new component that you have just built into a massive landscape of already existing solutions in an organization. Um, and I will walk you through basically the standard way of securing AWS services or interactions or callouts from AWS, as well as some network security as well, right? So a bit of everything. All right, so I told you that my application queries Elasticsearch. This Elasticsearch actually is not part of my AWS account. It is in AWS, but it lives in a different account. That account is managed by someone else. So I have to have proper authorization, obviously, to be able to retrieve data from that Elasticsearch. Um, Next, my application also interacts with ServiceNow. ServiceNow is actually totally outside of AWS. It's a cloud platform these days. It's deployed somewhere, and it's currently secured by so this is how our client decided to secure it. It is secured through IP whitelisting. I also use named credentials, so your standard basic authentication, but that's a fairly common thing, so nothing really to be surprised about. But there's also this IP whitelisting, and I will explain um, shortly why it makes things a bit problematic when you're using cloud and there's no way of having fixed IPs, because there isn't. Well, there is, but it's not easy. So let's start with how we interact with this Elasticsearch. So pretty much a standard way of interacting between services in AWS, especially between services in different AWS account, is this concept or principle of assume role. So assume role is an operation that that issues a set of temporary credentials. So there's a service called STS, Simple Token Service. That service is able to verify if a user calling it is authorized to be issued a set of temporary credentials, and if yes, those credentials are returned to the user for subsequent actual communication with services. So whenever we want to search some logs in the Elasticsearch in that account, we actually issue a query first to their simple token service asking for temporary credentials. So this Lambda that does that, it also has a role assigned. And this account has allowed this role to retrieve temporary credentials, or in other words, the security entity here, or the security principal, sorry, here, is authorized to perform this assume role operation. On its own, this guy cannot just query the Elasticsearch, but it can assume role, so temporarily become someone else and receive a set of temporary credentials that expire after a while. STS returns those credentials, and the next step is to sign the request with those credentials. This is a fairly complicated process. So you have to generate something called a canonical request. You have to sign the entire request payload, so the headers, the body, if any, the URL, the path, basically, so host name and path. That is pretty complex. Fortunately, we have a library. Well, this is a node-specific library, but there's plenty out there that does it for you. So using those credentials, it actually generates a bunch of hashes that then get attached to the actual request to query Elasticsearch. So this covers the authorization to Elasticsearch, right? Get temporary credentials, prepare an HTTP request, sign the request using signature version 4. This is an AWS term. There's a basically whole guidebook on how to sign those requests by AWS. Sign them with signature version 4. Only then can you issue a successful call to the service, in this case, Elasticsearch. So that is your Elasticsearch. Now, the more tricky part, in my opinion, was figuring out the network security, or rather, how to deal with your IP whitelisting and the fact that ServiceNow requires IP whitelisting. So there were two. So when I started looking into this, there was one approach that I had in mind. So basically, I wanted to route through on-premise because public customer IPs were already authorized with ServiceNow. For reasons that are beyond the scope of this discussion, routing through on-prem was problematic and of course inefficient, right? Like we this application doesn't really require much network throughput, but still that would be a waste of time to route through on-premise. So the other approach was to actually authorize some IPs from the cloud. Obvious, right? Thing is, you really don't have a way in AWS. Well, I'm hesitant to say that there is no way, but at least I am not aware of any way to permanently assign an IP address that never gets recycled and that never changes. There is something called bring your own IP, where you can bring a range of addresses that is assigned to your company to the cloud and use them as part of your in-cloud infrastructure. But actually, our customer that didn't have any IPs to spare, so we couldn't do that. So otherwise, there's no way to have a fixed set of IP addresses that never changes. And remember, these need to be authorized with ServiceNow so that we can communicate with ServiceNow. So the cloud team at the client, they came up with this. Or perhaps before I talk about that, I'll tell you how this is normally done. So normally you will have your you will have your elastic IPs that you provision when you deploy your resources, and provided that you don't delete the stack. A stack is basically a collection of resources that may constitute, for example, an application. So provided that you don't have a need to delete the stack, and you may, when you, for example, want to move resources to a different AWS account, or something really breaks and you have to drop and recreate an entire stack. If you don't do it, then those IPs should stay the same more or less forever. But if you do, and it is pretty likely that at some point you will have to, um, then you might have to, you will get a totally new addresses, random addresses that you will have to again go and authorize with all the external providers that you interact with. So, long story short, the cloud team at the client, they came up with this idea to have like a master network services account. So it still has the same problems, that if you ever need to move it, those IPs may change. But the idea is that from now on, every communication that needs to leave AWS and go outside to call some external service, it will be routed through through the network services account. That way, we only authorized a short, finite set of IPs, and that's it. And hopefully this will never change because that account doesn't store anything else than just those IP, elastic IPs or network interfaces. That's it. So this is how this was deployed. AWS has this concept of resource sharing between um, accounts in an organization. So if you have an organization is basically like a top level of account organization, yeah, of account structure if in AWS. If if you have an organization and a bunch of child accounts, it's possible to share resources between accounts in the organization. And this is what we did exactly. So they created a bunch of subnets in the network services account. These subnets were shared with my account to which Logmon was deployed, and from that moment onwards, I could interact with those subnets as if they were my own. So I deployed the Lambda that does the callouts into those subnets, and suddenly this Lambda always communicates with the outside world through a fixed set of IP addresses. That's why this could get authorized with ServiceNow, and hopefully will never change in the future. Yes, this should be the last slide, which concludes our session today. I hope you liked it. I hope it was inspiring. I know I couldn't, well, I had a very limited time, so I couldn't really go into too much detail. But I really wanted to just like, you know, give you some hints and tips and throw around a bunch of service names or components names so that you can see how they are used or they can be used in action. Yeah, and hopefully you will have some takeaways from this meeting. At the very end, I just wanted to say that I was thinking about making those tech talks somewhat more organized, perhaps even having a workshop form. So if you have ideas for the topics, perhaps we could talk about AWS, in detail, like have a set of tech talks on AWS, which would be basically workshops or classes kind of things. Or I also had in mind this idea to prepare from zero to developer series of tech talks where we will build a complete application with front end and back end, let's say Angular plus Lambdas plus API Gateway plus Dynamo in AWS. If you have ideas, if you would be interested in any particular topic, then just contact our PR department, contact us on Facebook. We would love to hear your feedback and perhaps we could accommodate some of those requests. So that was my pleasure to host you tonight. I hope you had some fun, and I do hope this isn't the last talk that we are having together. So don't worry about the virus. Live your lives, work, deliver, teach people, and believe that we can still effectively, most of us at least in the IT world, we can still effectively do our job. And if that's the only takeaway you take from this, and remember that it is still possible to a certain degree to have normal lives. If you ever want to reach out to me, you can find me on LinkedIn. You can mail me. I'll leave my work email in the chat. That was my pleasure again. And a talk on data lakes would be awesome. Yes, I'm actually personally very interested in big data. So I would love to host something like that at some point. It might actually happen. It might actually happen. All right. Thanks again. See you soon, guys.